H110. This is going to be lab 23 and 24. So with this lab, what we're going to be focusing on is three variable systems, but we're going to use the matrix feature of our graphing calculator in order to solve these. I'm not going to make you solve these by hand. So we're going to use that matrix method for that. So then we're going to use the RREF feature for reduced row echelon form. There's three different possibilities of things that can happen. You could have one solution, which in the case of a three variable system is an ordered triple, X, Y, and Z. You can have no solution, which means that the three planes do not cross in one spot. Or you could have infinitely many solutions, which could mean several different things, where the planes all cross on one line. Kind of imagine 3 pages of a book meeting at the spine of the book. That's an example of that. Or it could be a case where you have 3 parallel planes. Picture maybe on a in a classroom, the floor, the top of the table, and the ceiling are all flat planes, but they never touch one another or cross. So there would be no solutions to those. So there's different possibilities with the systems of equations. So what we're going to do is we're going to set up the matrix that we will need to enter in our calculator. Since we're dealing with a three variable system, we have 3 equations. So that's 3 rows, and then there are 4 columns. So it's a 3 by 4. The first column is x's, the second column y's, the third column is z's, and the fourth column is what the equations are equal to. So when you set up your matrix, you're going to have 2, -3, 4, -2. That'll be your first row. The second row, coefficient of x is 1, coefficient of y is 4, of z is -3, and 15 is what the equation is equal to. And then we have 3, -2, 1, and 7. So we need to take this matrix and enter it into our calculator. So we're going to hit second, X inverse, and then we're going to go to edit. I'm just going to use matrix A, and I'm going to change the size of it to a 3, enter 4. So it makes it a 3 by 4, and it adjusts the size. And then I need to enter that matrix. So 2, -3, 4, 2, -3, 4, and -2. And the second row is 1, 4, -3, 15. 1, 4, -3, 15. And the third row is 3, -2, 1, 7. 3, -2, 1, and 7. Verify that I've put everything in correctly, because one mistake on any spot can drastically change this problem. 2, -3, 4, -2, 1, 4, -3, 15, 3, -2, 1, 7. So I think everything is good there. Once I've done that, I'm going to hit second mode to get back to the regular calculator screen. And then I'm going to hit second X inverse to get back to the matrix menu. And then I want to press the right arrow key to get to math. I'll press the up arrow key to get down to the bottom and find RREF. Press enter. Second matrix, and I'm using matrix A. Hit enter, and here I get this reduced row echelon form 1, 0, 0, and 4, and then 0, 1, 0, 2, 0, 0, 1, -1. What this matrix tells me is that the first row says x is equal to 4, second row says y is equal to 2, third row says z is equal to -1. So we have an ordered triple of 4, 2, -1. That's x, y, and z. That's how the ordered triple is set up. Solutions to that system, 3 variable system of equations. They're using RREF with our calculator, which is the way that I prefer that you solve these. Let's look at example 2, different system. Again, it's going to be a 3 by 4 matrix. Coefficients 13, -3, -4, -10. And then -2, 1, -1, -6, 8, 3, -17, -74. Okay. So we need to put that matrix into our calculator, and so that we can use RREF to find the solutions of that, if there are any. So second matrix, or to edit, matrix A already has 3 by 4, so it's 3 by 4, and then I'm going to put in the matrix that I have there. So I have 13, -3, -4, and then it's equal to -10. The second equation, I have a -2, 1, and then -1, and then -6. The third equation, I have an 8, 3, -17, and then -74. Second, quit. And then second matrix, over to math, RREF. And which matrix did you put it in? I put it in A, hit enter, and there I get this matrix back. 1, 0, -1, -4, 0, 1, -3, -14, 0, 0, 0, 0. Here's what this tells me. Because that bottom row has all zeros in there, that tells me that this has an infinite number of solutions. So infinitely many solutions. Okay, and the way that we express those is we can write them in terms of a particular variable. So if we wanted to write these solutions in terms of z, which is a typical way of doing that, we can take the equations out of this reduced matrix. So this first line has x minus z equals -4. So I could take that and solve it for x by adding z, and x would be equal to z minus 4. So in my ordered triple, I'd have z minus 4 in the x position. Then I take the second row, and I have y minus 3z is equal to -14. And I'd solve that for y. So I add 3z. So y is equal to 3z minus 14. And then because we're doing it in terms of z, z is just the variable in the third spot. And we could pick an arbitrary z value and then find the x values that go with it. That would be a solution on the intersection of these planes, but not necessarily one spot in particular that they intersect with. Let's look at example 3. So another 3 variable system, 3 rows, 4 columns, x, y, and z. Make sure that they're in order, x, y, z, x, y, z, on all equations before you start. If they're not, you need to rearrange. So we have 3, 2, 4, 8, -2, 4, 3, -6, 5, 14, 18, 10. All right, so we're going to enter that matrix into our calculator and see what kind of solutions we get there. All right, we could have one solution, infinitely many solutions, or no solutions that could happen. And so let's enter that matrix into our calculator. Second matrix, go to edit. I'm going to use matrix A again, 3 by 4. So 3, 2, 4, 8, -2, 4, 3, -6, 5, 14, 18, 10. So I've entered in that matrix into my calculator. Second, quit. And then I'm going to use the RREF of matrix A again. So if I just press the up arrow key with my calculator, I can copy and paste by just hitting enter, and it'll copy that command down. But it reads the new matrix A that I've entered. So I hit enter there, and I get this weird looking matrix back. So it's got decimals in it, so I tend to usually convert those back to fractions. But I got a matrix here where I have 1, 0, 5 eighths, 0, 0, 1, 17 sixteenths, and then 0, and then 0, 0, 0, 1. And the bottom row tells the tale. So here we have the bottom row. It has 0x, 0y, and 0z is equal to 1. Well, 0 plus 0 plus 0 can never equal 1. So that tells me that this one has no solution. And that is all I have to do when there is no solution. It's also called an inconsistent system. So if it has a solution, it's consistent. And if it has one solution, it's consistent and independent. If it has infinitely many solutions, it'd be consistent and dependent system. If it has no solution, it's also called inconsistent. So those words can help you. But that is the method that I would prefer that you solve all the problems in lab 23 and 24 using. Math 110, lab 23 and 24.